Assalamu alaikum and good evening to all participants of today's session. Today we are going to present the BEAWorld webinar session number 65. Our topics today is the basics of B.Sc design and its practical implementation. Many of us we heard the phrase home, sweet home. Because wherever we go, after returning home, we feel the comfort like no other places in earth. However, this comfort is attached with emotion primarily. But technically, this comfort provided through HVAC system, because the HVAC basically designing the complete home comfort system that can heat and cool our home, as well as provide improved indoor air quality and humidity control. So I believe we are going to experience an amazing session with fully packed technical information about HVAC and our home comfort. This is going to add some values to MEP engineers definitely in their professional life. And now let us know a little bit about our presenter of today's session. Engineer Muhammad Ashraful, he's basically presenting our today's session. And he is a building services engineer with over 19 years of experience across UK, Qatar, UAE, and Bangladesh. He did his B.Sc in mechanical engineering from Kuwait and master's M.Sc in building services engineering from Leeds University. With a strong background in both contracting and consultancy, he specializes in the design review, execution, and project management of MEP systems. He has successfully managed many projects, holding key positions such as MEP project manager, lead MEP engineer, senior mechanical engineer in various projects. Currently, he is working in SYSTRA, based in Manchester, UK, and leading the mechanical design team for Dubai Metro Blue Line. His expertise spans HVAC, smoke management, water supply, drainage, and firefighting, and project management. And I'd like to add something that the knowledge across several MEP systems like electrical low voltage system, irrigation, fire alarm, BMS, CCTV, lighting control, access control, and many others. He excels at leading MEP team, fostering collaboration and ensuring timely, cost-effective project delivery. He holds certification as a project management professional and is a full member of IET, Ashrai, and possesses MME certification from Qatar and a membership in the Saudi Council of Engineers. I'd like to give the floor to Engineer Ashraful Alam to continue his presentation.
Thank you, Eskander bhai, for a big introduction. And welcome everyone to this presentation. My slides are visible, right?
Yes, it's visible, yeah.
Yeah, and I will just have a quick look at this one. That is it changing properly or no? Let me. The slides are moving, right?
Changing, yeah, it's changing. Yeah.
Okay, thank you. Actually, to this presentation, as Eskander bhai nicely described, that it is about the basics of HVAC and practical implementation. This presentation is not going to have in-depth technical things, nothing so special. It is as usual, as all of us know in our daily activities, especially those are working in the building services sectors. Either it can be the architect, the structural engineers, any building engineers, mechanical, electrical. So I tried to make it as simple as possible, and I will try to complete all my slides if possible within 30 to 40 minutes maximum. And remaining 20 minutes, I would like to have the open discussion among all of the engineers, because I realize by attending most of the sessions that many engineers we are having in the webinars who are having a huge experience, So it is beneficial for all of us to have some open space so that we can discuss together and we can share our knowledges and experiences. So without further ado, let me go through the slides that I prepared for this webinars today. So first of all, I will start with what is HVAC. So HVAC is heating, ventilation, and air conditioning, I think. So why we need HVAC or how it works actually? So let's say a very simple thing. Means let's say we are coming from outside to our houses, and once we enter our house, then sometimes we feel in winter season we feel it is cold. If it is a summer season, we feel it is hot. Maybe the building or the room was not used for several hours or for several days even. So when we enter first time, we may feel smelly, some odors or something like this. So that is why we need the HVAC. So what we do, we go inside our building or inside our house, and we switch on our HVAC system if the building has it. So first of all, the problem. So a building gets hot, cold, dusty, or humid. So first of all, we switch on the HVAC system. So what happens when we switch on the HVAC systems? How the HVAC system understands that what is the requirement. So HVAC system has sensors which senses the temperature, the humidity, the CO2 level, the fresh air needs. So based on this sensing, he activates, he takes the action. What the actions can be? He cools the air or heats the air. If there is a dust or viruses inside in the air, so he filters that. He brings the fresh air from outside and removes the smoke or bad air, whatever is inside the room. So what is the result of that? Then we feel better, comfortable, and the environment becomes healthy for us, safe, and we become more productive. As we see now, means I will go to the next slide, then I will explain that one. Okay. In short, in super short, HVAC is the system that controls the temperature, airflow, the air quality inside a building. It makes indoor spaces comfortable, healthy, and safe. But does only HVAC does that, or anything else also we need? So this is a common thing we need. All are aware about this one, whoever working in the building sector. So let's see why HVAC. So for our comfort and health in the building, we need to have proper indoor environmental quality. So what is that indoor environmental quality? So in that we have the lighting quality, acoustical quality, air quality, and thermal quality. So now let's move to the next slide and see how these are impacting our comfort and health. So this is a chart actually. It is showing the stressors as acoustical quality, indoor air quality, lighting quality, thermal quality on the left column. And in the middle, we can see what the stress mechanism this creates. And in the last, we can see the diseases and disorders. So if we have an acoustical quality issue, it creates anti-stress and it ultimately affects in the depression, and you can see the depression, obesity, diabetes, chronic respiratory diseases, cardiovascular diseases, cancers. All these diseases somewhat related to the environment, indoor environmental quality, which are acoustical, indoor, lighting, and thermal. So in this one, the acoustical quality slightly related to the HVAC system, indoor air quality completely, thermal quality completely part of the HVAC. So if we just ignore the lighting quality remaining and partly the acoustical remaining, most of it are related to HVAC. So for our everyday performance and our well health being, HVAC is very important. Especially nowadays, we spend 80 to 90% of our time inside a building nowadays. So, and especially those who are working in the offices, means many people are coming over there, mingling together. So this affects our health and well-being and overall our performance in the office. So let's say uh, acoustical quality. What is that acoustical quality? Acoustical quality is the sound level, frequencies, duration, absorption, characteristics, insulation, reverberation, time. What it does, the HVAC system, we can acoustical control, design, facade insulation, construction, HVAC, passive noise control, active noise control. This all can be implemented to do the acoustical quality. Now, visual quality, it is the lighting quality. It depends. I will not go through this one. And the indoor air quality. So this is very important for the HVAC, indoor air quality. So we can see there are few diseases like asthma, allergic rhinitis, hay fever, COPD. So all these are we may have affected by all these diseases if we don't have proper indoor environmental quality. So what happens when indoor environmental quality is not properly maintained in a building? That building, we call it as a sick building. And how to understand that the building is sick? We can see a list here, which is saying the dry eyes, itching or watery eyes, stuffing nose, running nose, sneezing, dry throat, lethargy or tiredness, headaches. And nowadays we see that we maybe almost some of it means affecting our daily life now and then, frequently. So we don't understand most of the times that why this happening. Maybe some of us say, okay, because of the mosquito, because of the dust, but many of these are actually happening because of our building conditions where we are living. Next slide. The thermal quality, that as we know, this is regarding the heating, cooling, and the air conditioning of the building. So this is having the air temperature, surface temperature, relative humidity, air velocity, turbulence, activity, clothing, all are related to this thermal quality. So that was the brief discussion about why we need the HVAC and how HVAC can improve our everyday life. So now come back to the HVAC basic things, means how to design an HVAC system. Excuse me, it is cold here, so I'm maybe my building is also a sick building. So how to design an HVAC systems? Here I tried to point out some common points actually what we need to do to design an HVAC systems. Razabai, my voice and everything are clear, right?
Yes, everything clear.
All are fine. Okay.
Yeah.
Okay.
Please carry on. Yeah.
Thank you.
It's nice to hear. No problem.
Okay. So I pointed out 8 points here. The first one is the load estimation, system concept selection, equipment selection, distribution, control and BMS strategy, acoustics, vibration and fire safety, energy and sustainability analysis, detailed design documentation. So if we try to find out the major few things for design, so I would say that the first 4 points. So and all these points cannot be covered to the session. So I will try to slightly go through the load estimation, actually how we do that. And this is also a very basic thing I will be pointing out here. So it will be, I believe, understandable to all of us, irrespective of which discipline. So the load estimation fundamentals here. So how we do the load estimation actually, because I think we know the first law of thermodynamics, which is saying that energy cannot be created, neither can it be destroyed. It can only be converted from one form to other. It is saying Einstein, it is not Einstein anyway. So what happens in a building? If a building is hot, That means we need to make it cold so that it will be comfortable. And if a building is cold, we need to heat it so it comes to the comfortable temperature. So when the building is hot, that means we need to take out some heat from that. And if the building is cold, we need to add heat inside that building to make it comfortable. So this is what it is showing actually, that if the energy is inside, that energy has to be out. Either the energy is either positive or negative. So that is what we are doing actually in air conditioning. So in air conditioning, as we said, the how to deal with that heat. So when we are dealing with heat, we have actually 4 types of parameters we are dealing with. The first one, we can see the transmission, which is happening through the building envelope. We can see the building here. The heat is moving out because the indoor temperature is 20 degrees centigrade. And second point is ventilation and infiltration, which is the air coming in and out of the building. The third is solar gains, the solar radiation which is coming inside the building. And the fourth is internal heat gains. This is the people, the appliances, the lightings, what we use inside the building. So first, let's say the heat transmission. In a building, how the heat is transmitted actually. Heat transmission is through walls, floor, roof, and windows. This is the common thing in any building. These are the items we have in a building. So this is transmission, and the equation is very simple here. I think this is intermediate level equation, like Q is equal to U A del T. So the most important part here is U value, which is heat transfer coefficient. So usually when we do the buildings and we select the walls, these walls are actually selected mostly by the architects or the civil engineers. But what happens in many cases, if the architect or the civil engineer is not concerned about the load inside the building, then the selection might be wrong. This is where the energy, sustainability, and other terms comes in. Nowadays, most of the heat radiation means the load related and energy efficiency related courses are offered by the architectural departments in many universities. The reason behind that is because the architect is the first one who must know that what type of building envelopes should be used so that the building becomes energy efficient. But in practical, what happens when we study the mechanical, civil, and architectural, actually the architectural and civil, when we move to the practical field, mostly getting detached from this type of things. So I think this is very important for all of us who are working in the building sector to understand the effect of U value and how it affects the overall HVAC system and the building energy efficiency. So this is this point. The next point is ventilation and infiltration heat transfer. So there can be natural ventilation, mechanical ventilation, these 2 types. And the equation is very simple here. I have written this one. This is also a very simple calculation. I will move to the next slide, which is infiltration losses gains, which is due to the building cracks, leaks, the orientation of the building, the external air pressure. So all this affects that one. And this one is load estimating solar heat gains. So most of us, when we first look at a site and we think about the building orientation, this is one of the most important point we need to take care of it, that the building is oriented in which direction, so the solar heat gains is considered during the design phase. Next is internal heat gains. So internal heat gains is the people who will be using the building or the space, how many people will be inside the space, how many lights will be there, how many appliances will be used. So if we are using, let's say, if there are 3-4 people, so the load for 4 people will be calculated. If we are using 500 watt lights, then that energy will be accumulated in the HVAC loads. And if we are using computer and many other appliances, printers or whatever it is, all these loads will be calculated as a heat gain and will ultimately affect the HVAC loads. So these are all the loads we need to consider for an HVAC load calculation. So what we see now, we saw the conduction, which is happening through walls, roofs, and the floors. And we see the convection, which is the air movement, and radiation, which is coming from the solar, and role of U values and material properties, which is greatly affecting the overall load of the HVAC systems for the buildings. So this is about the load actually. So this load is very important for the HVAC system, because the first thing we do is the load calculation, and then later on this load is dictating what equipment and what type of equipment, and how this will be controlled, what type of control, all other remaining items. So if we summarize this one, the load calculation actually covers the building envelope heat gains, occupancy, equipment and lighting loads, ventilation and infiltration loads, and we need to study the psychometric, we need to do the psychometric analysis, and what is the peak load for cooling and heating, and we need to consider the annual energy performance also. And this whole, after analyzing this whole thing, we will get the output as a total cooling, heating load and air flow requirements. Now if you move to the second point, which is the system selection. So we have the load now, we know how much heat load or how much ventilation is required. So overall information we have. What we have is the heat load, and we have the ventilation requirement. So now how we need to fulfill that requirement. Here comes the system selection. So in system selection, what are the things we need to consider during a system selection, and what are the systems? We need to select the system type, what type of system. If it is a small building, maybe we'll go with DX only for few rooms, or VRV systems. Or if it is a big building, maybe chilled water system will be more beneficial and cost effective. And sometimes, you know, big areas, district cooling system is also used, where instead of using individual building wise chillers, the chilled water is supplied from a district cooling plant to the individual buildings, and from that buildings through heat exchanger it is distributed. And for the building itself, we have to have some units inside the building, inside the room. Usually we see inside the split units, if it is a DX unit. If it is like central unit, we see the FCU. And AHU, we see central systems only. And we have the ventilation strategy. Ventilation strategy is having natural plus mechanical ventilation systems. And we need to do some zoning actually. Zoning, indoor air quality requirements as per Ashraful, integration with architecture and space requirements. This is a very important thing actually, integration with architecture and space constraints, because in large buildings, the ducts usually coming out from the roof or the plant rooms has to go through the corridors or the risers, and it has to go inside the spaces. So keeping those spaces for the ducts and the pipes, what is required for the HVAC system, that has to be properly coordinated with the architectural, for the architectural aesthetic perspective, as well as the space constraints. And we need to think about the energy efficiency for the whole building. This is very important nowadays. So this is what we need to consider for the system selection. And if we come to the equipment selection, the equipment selection will be dictated, as I said before, considering the load calculation and the system selection will affect the equipment selection. It can be chillers, boilers, heat pumps, cooling towers, HU, PAU. There will be pumps, fans, heat exchangers, filtration strategy. So all these things, and after analyzing all these things, we'll come to the equipment data sheets, capacity verification, manufacturer coordination. So distribution, the fourth part will be distribution and transportation systems. Here is we are saying that how the distribution will be done. If we are having a DX unit, let's say, which we are seeing in normally the split units we have in our houses, this is having an outdoor unit and indoor unit. So there is no ducting actually, there is only a piping connection. But what if we have a central building? The AHU, air handling liquid, will be on the either on the roof or the plant rooms, and also the chiller will be somewhere else. So the ducting and piping has to come to the space. So how it will be done? So we have the air distribution and we have the water distribution. What is there in the air distribution? That in air distribution, we need to design the duct, the outlets, the diffuser grills, sound attenuation, and duct lining. Here is the acoustical thing. If we just leave the equipment running and without any acoustic treatment, we supply the air through the grills or diffusers, what will happen? The equipment noise or the air noise, it will always be coming to the space. Yeah.
Ashraful, I'm sorry for the interruption. Mr. Paul, may I request your attention, please? Mr. Paul? Mr. Paul Shashwat Menon, can you please switch off your video? Mr. Paul Shashwat Menon. Mr. Paul Shashwat Menon, can you please switch off your video? It's distracting the presentation. He's not listening. Anyway, Mr. Astra, please continue.
Okay, and give me a shout if it is getting too much boring. Yeah. Because I'm mostly emphasizing on the discussion we will have at the end of the slideshow. So I will continue. Eskander bhai. Hello, Eskander bhai. Yeah, I'm continuing.
Yeah,
okay.
Please continue. Yeah, sorry
Sure.
for interruption.
It's okay. So here is the distribution and transportation. Yes. So as I was saying that the acoustical things we need to take very careful consideration. Otherwise, the AC, the air conditioning will be there, the humidity will be controlled, the temperature is very good, but always there will be a noise and it is very annoying. And we know that noise disturbs our hearing capacity, and also it has a very many adverse effects. Maybe many of us are not aware of, like as I showed in the beginning of the slide presentation, that cancer, depression, and many things are affected by the air quality. So and the water is actually the water distribution also, because the central unit, which is located in the either in the roof or any other plant areas, has to run all the way to the rooms. So that pipe sizing, pump, head calculation, valves, strainers, whatever is required for that. So all these are part of that water distribution. So now control and BMS system. So now we have the plants, we have the heat load calculation. And from heat load calculation, we selected the system. And based on the system selection and heat load, we selected our equipments. Now, after selecting the equipments, we have our distribution, ducting, piping, everything we have. Now the full system is there. Now what we need to do, once we switch on the HVAC system, we want that system to work properly. So who will do that? That will be done by the control and BMS integration. So let's see what are the points here. The temperature, humidity, pressure control, the VAB, VRF controls, chiller sequencing, pump BFD control, CO either or CO2 based ventilation control, the smoke control, which is part of the fire and life safety, integration with BMS, SCADA. So all these things will be involved over there, and the output will be control diagrams. We will have for the BMS IO list and the sequence of operation. These will be the output of the all these design considerations for the control. Now let's move to the next slide. Acoustic, vibration, and fire safety considerations. Acoustic, I already explained, so I will not go into that once again. The vibration is also part of actually vibration, acoustic and vibration. These two are usually studied in the same section. Vibration means the equipment where we are fixing, whether the vibration of the equipment is getting transmitted to the adjacent floors or adjacent rooms that we need to take care of, and fire safety is the most important part. A building's fire nowadays mostly depends on the smoke management and fire safety precautions we take in the HVAC system. So this is a very, very important and something that must be maintained in a building. There is no consideration in this one. Even the cooling and other stuffs are not that good, but fire safety requirements must be fulfilled in any building. Otherwise, our buildings HVAC system will not be approved by proper authority. So the sound calculation, yes, for the acoustic, we need to do the sound calculation. We have some noise mitigation strategies like attenuators, barriers. We are using springs, inertia bases. And as I was saying, the fire for the fire control, we use what we do in the HVAC system. Mostly, we use the fire dampers, smoke dampers. We use the pressurization fan, smoke control fans, and we have some smoke curtains and other stuffs as a barrier, which is also sometimes considered as part of the HVAC. So this is the acoustic, vibration, and fire safety. And I will go to the energy and sustainability analysis. This is a specific, if there is a specific requirement in any project, then it is done. Otherwise, for small projects, mostly people are ignoring this one. So I will not go through these things. Then I cannot complete my slides on time. Just it will be there. So detailed design documentation means after we do all these things, then we will have some outcome documentations, which are this one: the HVAC drawings, schematics and risers, BOQ and specification, design report, coordination with architectural, electrical, fire safety. I don't want to go through all these things, important components of HVAC systems. So for properly understanding and designing HVAC system, it is very important to understand how the cyclomatic chart is working. There are a few points. These also I will not go through. I think whoever is working in the HVAC sector, he already knows this one. And for in general other engineers, I think it's not that important to understand, but it is there in the slides anyway. Air handling unit components. Usually air handling unit, you have the mixing box, filters, cooling, heating, humidifiers, all these things. I will not go through. Fan fundamentals, few items. If somebody wants to go through, he can go through. So basic understanding. Chillers working. So we have a lot of type of chillers, heat pumps, and modern HVAC trends. These also are duct design principles. Chilled water system design. What are the conditions for chilled water system design? Even if I explain, I think people will forget this one. Control as BMS integration. That is what I explained. Just so now that was my presentation actually, but I will highlight one last point actually from my experience. So I thought it would be great to share here. So actually, our company did the Wakif underground car park, which is in Qatar. So there are few challenges I will just like to share here that for that project. So cognitive baseline challenges. Actually, this was the project had only the ventilation system, and mostly it was for the smoke management, and it did not have any HVAC system for the cooling and humidity control. So it was an existing car park, underground car park. It had the two basements, and our duty was to do the air conditioning for that. So if we see there, existing ventilation system was there, and for the ducting, no space was kept over there, and for the AHU also there was no space. So we had to accommodate all these things. So here comes the issue that whenever we introduce something to an existing building or even in the new building, we need to always coordinate our ducting, equipments, and everything with the architectural and structural teams. This is very important. So what challenges we faced in that project? The temperature, as we know, in Qatar, Middle East, the external temperature is 46 degrees centigrade, and the relative humidity also was very high, and we have to maintain 28 degrees centigrade and 50% relative humidity there. So what we did actually, because that was a existing project, and we have to do design, and then that design has to be feasible, and we need to practically demonstrate that whatever system we are implementing, it is working. Nowadays, because we don't only do the design, install, and finally we do the testing and commissioning. No, from the design stage, we need to make sure that whatever design we are making, that is going to work. Earlier, maybe there were many projects we were not doing any CFD analysis, but nowadays it looks like CFD is very important. Means it is one of the most important part of HVAC design and even the building design. Sometimes nowadays we see that even for small things, maybe we can say that, okay, 90% okay, I can confidently say this design is going to work. But even though the client is asking, no, I need to see that your system is working. So what is the way of doing that? CFD analysis. So in this project, what we did the CFD analysis. For CFD analysis, yeah, most of us know who are involved in this, then that we need to make the 3D geometry preparation, mesh generation, defining boundary conditions, transient solver configuration, and how we interpret the CFD result, velocity vectors, streamline analysis, temperature gradients, identifying recirculation pockets, time required for thermal decay. I will just quickly go through, then I will explain the whole thing in a nutshell. Optimization measures applied. Modification of supply and return position, enhancing airflow mixing, reducing dead zones, validating design selections. So if I say in a nutshell, what is this CFD analysis? I think this is very important for all the engineers working in the building sector. Let's say for any room, a big auditorium or something like this, which is having floor area, let's say 100 square meter. So in that 100 square meter, we design the HVAC system. So now, okay, we designed the HVAC system, but inside that room, there are few cabinets, there are many equipments are there, computers are there, servers are there. Let's say all these are inside that 100 square meter room. So when we design in general, we consider the whole 100 square meter, what is the total equipment load is there, how many people will be there, and how many lights will be there. But we are not specifying exactly where that equipment is there. Let's say I have a big equipment which is having like 1 kilowatt capacity. It is coming in one place. But when I did my load calculation, I considered the whole 100 square meter. But this 1 kilowatt load is coming one point. So if I give the proper distribution in the whole area, 100 square meter, it will not be serving that 1 kilowatt load in one corner. That area will be heated. So how to resolve that issue. That means we need more cooling over there. And even if we giving more cooling, is it sufficient for that or no? So how to verify this one? So we need to make the real 3D view, means the 3D drawing for this one, for the room, the actual how the room is, and we need to show how the air is distributed and where the air velocity is how much and what is the supply air temperature. Everything we need to put it in a real case scenario simulation. And that simulation we need to run, let's say, for 1 hour, 2 hour, 3 hour. And we need to consider a few other things, like maybe the whole night that building was switched off, only the equipments were running for the computer and other stuff. And then maybe somebody switched off the HVAC also. The next day morning, when somebody is switching it on, that means the room is hot, or maybe the room is not in a comfortable condition. So how much time this HVAC system needs to make that area comfortable? That is another consideration. Let's say I have a seminar tomorrow morning, 9 o'clock. And just 10 minutes, 5 minutes before, somebody, security or somebody, means opened the room and he turned on the HVAC system. So when he did that one, the room needs to be in comfortable state, maybe half an hour or 1 hour. So, but after 5 minutes, the session is going to start. So everybody is there and they are feeling hot, not comfortable. So we need to know how much time this room, the air conditioning system, has to run to make it comfortable. So if we know that it is half an hour, then the security or whoever is going there to the room, he should switch on the system half an hour before the session starts. But usually it is not done by nowadays, not by security or anybody. It is done by the building management systems. So the building management system is directing when the system should run, when the system should close. So all these are coming from where? The CFD analysis. And also the CFD analysis is giving us exact data that where the airflow is not correct, where the area is getting more heated. So based on that CFD result, the ducting arrangement, the air outlets, and the load distribution, everything has to be reshaped. So it is a process. If we, in a nutshell, if I say it is an iterative process that we design based on the standards and our knowledge, everything we put it together. Then we design the basic HVAC system. Then we do the simulation. And once the simulation passed, then it is very good. But usually simulation is saying, no, you did not do good in that area. So we need to modify that area and we need to run the simulation again. And we need to make sure that the system we designed is perfectly working. So when we go to the execution and final testing commissioning, we are not having any surprise that, okay, oh, now this is not working. And if something happens, we can identify that why it is not happening, since the CFD was verifying that one. So this is very important, what I thought of about this HVAC basics. And so and I was thinking like the load calculation is very important for everyone to understand, because that is related to all disciplines. And this CFD analysis is also very important, because it is not only the HVAC engineer, the architect has to do the architectural aesthetic perspectives and the lighting and other things, considering that nothing is blocking the air movement. These are means some sort of coordination in between the architectural, structural, and the MEP engineers. So these two things are, I think, very important for all the engineers working in the building services section. So that's it actually for my presentation today. And there are for installation challenges. I don't want to go through all these things. So thank you everyone, and I would like to start the question and answer and the general discussion, so all of us can share our knowledge and get something from today's session. And also yeah, that's it. Eskander, right?
Yeah. Thank you very much, Engineer Ashraful Alam.
Yeah.
for such a powerful presentation about our quality of living and especially how we can achieve it. So the definition of sick building actually is not new for us. For many of us, because we are engineer, we know about this, we are familiar. But for the other people, definitely this sick building definition actually is really necessary. And there are so many factors for our comfort living. Actually, it came out from your presentation. Definitely, I'd like to thank you very much. And I have to have like a special thank you for one of our participant, Paul Shashto Menon. We enjoyed actually his dance while he was while the presentation is going on at that time. I request you always to keep your video off always when you are participating in any presentations, because it's really distracting for any presentations. Now I'd like to go to our participants for their feedback and questions. Please raise your hand and or write your questions in the chat, and we'll be very happy to provide the information you need to know. Mr. Apsar Chaudhary, please unmute your, yeah, please go.
Yes, thank you, Joe. I'm really happy to see the slide and everything. Actually, my question is right now the HVAC basic design is for the engineers is familiar to all, but really applicable in the building and all the BMI system, especially to design in Revit or the HEP. That software almost using all over the world. Especially, I am just right now in Dubai. Even we have a little theoretical knowledge is even lacking, but they are using applicable software HEP and Revit. So on that two software, how we can use in more easily, because it is actually is a prime version. But normally we know the theoretically, but we have to get the job. This is most crucial issue for all. Thank you.
Okay, thank you for your question. Your question is very practical, actually. Yes, and after I answer, I will try ask for your feedback also about my answer. It's a back and forth discussion type of thing. You rightly said. Actually, most of the designs, I think, as of now, most of the designs I had in the buildings for the HVAC, it was done by the HAP software, which is hourly analysis program, which is made by the carrier. And the older versions of HAP, actually, this is like manual calculations. As you know, already you did. All the parameters we need to input by hand, manually, one by one. And this has almost no relation with the Revit. The Revit is like a 3D representation for the building structure with the actual items. All we can do, the Revit is giving us one benefit, that Revit has all the building elements. So if the Revit design is done properly, we can take the U values, the building construction type, manually from Revit to the HAP. And then it is easy for the whoever was working in the HAP, it is easy for him to take the data from Revit and give the input. But the latest version of HAP is having modeling option also. This is the very latest version. I think the version is 6.12 or something. The modeling can be done in the Revit itself, the HAP itself. But even though the modeling can be done, this model in the Revit cannot be imported here. It is like an individual model. We need to make it in the HAP. Like there is another software, IESVE, which is having actually modeling option. It is like from last couple of years, it has been in the market, and you can make the actual model in the IESV software, and from that model it can make the HVAC load calculation and other stuffs. And now the Revit thing, one good thing in the Revit is that few CFD analysis softwares, they can be integrated with the Revit models. So the CFD, when someone does the CFD analysis, it somewhat helps them if the design is done in Revit. But still, most of the CFD analysis softwares, you need to do the modeling in the software itself, but with some support of the Revit. The most important benefit of Revit is all the information. If we use the building information modeling, then of course we need to go with the Revit, because Revit and few other softwares, they can only have the full information of the building. If we do like AutoCAD or some, it's not possible. And one more thing, another good thing in Revit is that it can be done in a remotely, means let's say even 100, more than that, people can work simultaneously on the same model, and it can be federated and generated the complete building. I think I covered all your points you asked. If something not, you can give me the feedback, or if you have any observation on my answers.
Yes, you are right, but the most of the Bangladeshi engineers is actually they're just behind here. Only they doesn't know how to use the Revit or they knows basically they're theoretically very good, but in the job field they didn't learn that HVAC due to lack of software. They have no prime version in the country, I think. So you are now already such a person who work like that field. So through you, I am just actually messaging the news to convey all of our younger engineers who is just trying to come in here. Okay. Thank you.
You pointed out a very nice point, actually, very important point. I would like to say something after your feedback. Everybody means I will say it, emphasizing on this one. The HVAC is having a free versions also. So there is license version, of course. The free version is mostly available, and anybody can try this one. It's very easy. Means there are tutorials. It's very used to use. Means very easy to use. And as an HVAC engineer, if I'm not wrong, I can tell you that this is something you must learn. There is no why. There is no why. You must learn the HVAC, and then you switch to other software or something. That is a different thing. And one more thing I want to emphasize, that the demand of building services engineer, it is going high and high. And people are getting more concerned about their health, safety, and all the other stuffs. And as I said in my presentation, that 80 to 90% of our time nowadays in the urban areas, we are using inside the building. So the concern for the requirement of building services is becoming higher. The demand is going high and high. So there is a huge opportunity for Bangladeshi engineers specifically to move into this sector. And really, there is a huge demand. And I would suggest new engineers to move further and learn the new things and get connected with the seniors who are already in this sector. Yeah. Thank you.
Engineer Ashraf, thank you very much for your suggestions. Actually, related to this, there is one question came in the chat.
Yeah.
Mr. Shohak Hussain, he asked, if anyone wants to become a successful building service engineer after graduation in Bangladesh, what should be the right path to do?
The right path, you find the right person first and take his advice.
No, actually, the main intention, I think, for Mr. Shohak is there is no building service engineering department separately. Like, I mean, whatever you have achieved, I mean, in a master's, it's not like that. So to become a building services engineer, it is not an electrical engineer, not a mechanical engineer, but to study building services engineer specifically, then what should be the path? Maybe this is his intention.
Oh, this is his intention. But
yes.
I would like to say, my answer means I would not suggest anyone to go for the masters in building services engineering, because it looks like building services engineering. Actually, it is not covering the whole all the subjects, because building services means there is electrical, mechanical, plumbing, drainage. So a lot of stuffs are there. So when we do the masters in building services, like I am having the background as a mechanical engineer. When I did my masters in building services engineering, I took there is a you will be able to choose your subjects and the research area and which way you want to go. So because I'm a mechanical engineer, I selected the HVAC and other related stuffs, and I did my masters mostly based on that. So if someone is electrical engineer, he should be doing the building services, like maybe he will do the lighting, the energy simulation or something like this, and his emphasis will be on that sector. So if somebody wants to be involved in the building services, from my experience, what I can say that the first thing is to, after graduation, getting into the building sector, then working a few years. Then if he thinks that okay, this is my path, I would like to be specialized in lighting design or energy calculation, or in HVAC design or firefighting, then he can look for specific universities or subject areas to move ahead with that. And in parallel to that, also, I will say one thing: if somebody has interest to work in building services, you can take the membership from the Chartered Institute of Building Services Engineering, which is called SYSTRA. You can be a member of that as a student, as a graduate engineer. The charge is not that much, but in case even you don't want to pay that charge, also just be a just log into their system and see what is happening there.
Okay, thank you. I think I got
my
good answer.
suggestion.
Yep. Then it was raised hand by Mr. Muhammad Suleiman, and he wrote his question is, what is dead zones?
The dead zones means dead zone is where the HVAC is not working. Means dead zone means how to tell you this one. Let's say same thing. I will go 100 square meter. In that 100 square meter, we distributed the diffusers. So what is happening, because of the architectural or structural obstructions, there is one area where there is no air movement. The supply is coming, then it is not going there in that specific area properly, and also when the return also not coming. So there is the dead zone, means the air is stand still over there, means nothing is happening. So that is the dead zone. What happens by CFD analysis, we can understand that in some area there is a dead zone, means the air, there is no action is happening in that area of that dead zone. So CFD can find out that dead zone, and then we can find a solution to resolve that issue, modifying, either giving some specific supply diffuser or to serve that area, or somewhat to change the architectural shape, or if this is a structural element, what can be done for that. So that means that the coordination has to be done and resolve that issue. I hope that answers the question.
Thank you very much.
You can give me the feedback if I'm not answering the question properly. Actually,
Muhammad Suleiman, if you are there, yeah, please provide your feedback. I think he got the right answer. So let's move on to the next participant. Actually, someone showing the ESL projects.
Thank you again.
Yeah, Gigi বলেন।
রেড জোনটা বুঝলাম যে যেখানে এয়ার মুভমেন্ট হবে না। তো আপনি সেফটি অ্যানালাইসিস বলছিলেন, সেটা কি ডিজাইনের পরে আমরা ইনস্টলেশনে যাওয়ার আগে সেফটি অ্যানালাইসিস করে আমি ডেড জোন বাইর করব, পরবর্তীতে আমি ডিজাইন রিভাইজ করব, রাইট?
জি সেফটি অ্যানালাইসিস বেসিক্যালি করি আমরা নাকি? জি সেফটি অ্যানালাইসিস হচ্ছে বেসিক্যালি ইমপ্লিমেন্টেশনে যাওয়ার আগে। জি, ইমপ্লিমেন্টেশনে যাওয়ার আগে, জি। এইটা হচ্ছে আপনার ডিজাইন যে আমরা করছি, এই ডিজাইনটাকে ভেরিফাই করা, আসলে ডিজাইনকে ভেরিফাই করা প্লাস রিফাইন করা। আমরা নিজেরা যত ভালো ডিজাইনই করি, আমরা জানি যে আমরা যখন প্র্যাকটিক্যালি এক্সিকিউট করার পরে যখন আমরা টেস্টিং এর ব্যালেন্সিং এ যাই, তখন আমাদের অনেক সমস্যা চলে আসে। দেখা যায় এক জায়গায় কুলিং ঠিক মতো হচ্ছে না, আরেক জায়গায় কুলিং বেশি হয়ে যাচ্ছে। তো যেটা হয় সেটা হইতেছে গিয়া, আমাদের সব নলেজ, সব এক্সপিরিয়েন্স দেওয়ার পরেও এটা ক্লিয়ার হয় না। কারণ হইতেছে যখন প্র্যাকটিক্যালি করা হয়, তখন প্র্যাকটিক্যালি আপনার আর্কিটেকচারাল বা স্ট্রাকচারাল বা অনেক ইকুইপমেন্টের পজিশনের কারণে আমরা যেভাবে ডিজাইন করছিলাম ওই ডিজাইনটা আসলে তখন আর ফিজিবল থাকে না। তো সিএফডি করার মেইন উদ্দেশ্য হলো আমরা যখন অ্যাকচুয়াল ওই রুমের ভিতরের কন্ডিশনটা কি আছে, ওই কন্ডিশনে আমরা যে ডিজাইনটা করছি এখন এটা কতটুকু এফেক্টিভ। যদি সে দেখে যে এটা অতটুকু এফেক্টিভ না, তখন আমরা তখনই ডিজাইনটাকে একটু মডিফাই করে ফেলতে পারি। মডিফাই করে একদম মানে যতটুকু সম্ভব প্রিসাইজ ডিজাইন করা। এবং আরেকটা জিনিস হইলো গিয়ে, আমার ডিজাইন করার পরে যারা বিল্ডিং ওনার বা ক্লায়েন্ট সাইডে যারা থাকবে, ওরা তো আর আমাদের মতো এইচভিএসি ইঞ্জিনিয়ার না। তো ওরা কিভাবে বুঝবে যে আমি যে ডিজাইনটা করছি এই ডিজাইনটা থেকে সে স্যাটিসফাই হওয়ার মতো এবং সে নিশ্চিত থাকতে পারে যে এটা দিয়ে কাজ করবে। তো এই দুইটা সেন্সেই আপনার সিএফডি অ্যানালাইসিসটা করা দরকার।
প্র্যাকটিক্যালি এটা
জি,
প্র্যাকটিক্যালি আমি কয়েকটা প্রজেক্টে কাজ করছিলাম, 3D তো করেই না, এগুলো 2D দিয়েই করে মেনলি। প্র্যাকটিক্যালি এগুলো সিমুলেশন করে না, বাংলাদেশে প্র্যাকটিস নাই আমি যতটুকু দেখছি আর কি।
আমি আপনার একটা রিসেন্ট একটা কথা এক্সাম্পল দিই। আমাদের প্রজেক্টে ট্রান্সফরমার রুম আছে। ট্রান্সফরমার রুমে তো নরমালি যদি অ্যাবভ গ্রাউন্ড ট্রান্সফরমার রুম হয়, তাহলে সেইটার ভেন্টিলেশন হইতে হবে ন্যাচারাল। তো হ্যাঁ, যদি এটা ওয়াইল্ড টাইপ ট্রান্সফরমার না হয়, ড্রাই টাইপ ট্রান্সফার হয়। আচ্ছা, তো সেইটার যখন ন্যাচারাল ভেন্টিলেশন করতে হবে, এখন আমাদের চ্যালেঞ্জ হইতেছে গিয়া ন্যাচারাল ভেন্টিলেশনে বলা হয়েছে কি আপনার ট্রান্সফরমার রুমের দুই সাইড থেকে ভেন্টিলেশন ও লোবার থাকতে হবে, যাতে এক সাইড থেকে এয়ার ন্যাচারালি ঢুকতে পারে, আরেক সাইড দিয়ে বের হয়ে যেতে পারে, অথবা নিচে দিয়ে ঢুকবে, উপর দিয়ে বের হয়ে যাবে। এখন
লো ক্যাপাসিটির হলে ন্যাচারাল ভেন্টিলেশনে হবে, কিন্তু যখন হাই ক্যাপাসিটির হবে তখন ফোর্স ফ্যান লাগবে হাইড্রোলিক কুলিং করার জন্য।
জি, তো এখন যখন ন্যাচারাল ভেন্টিলেশন আমার দিতে হবে, তখন আমার দুই পাশ থেকে যেরকম স্ট্যান্ডার্ডে বলা আছে, দুই পাশ থেকে লোয়ার দেওয়ার মতো পজিশন এই প্রজেক্টে আমার নাই। আমি দিতে পারবো হইতেছে গিয়া সামনে দিয়া আর সাইডে অল্প কিছু জায়গা। এখন আপনি ন্যাচারাল ভেন্টিলেশনে সাইডে আর অল্প সাইডে আর সামনের জায়গা দিয়ে যদি আমরা লোবার দেই, তাহলে এইটা কাজ করবে কি করবে না, এটা আপনি কিভাবে ভেরিফাই করবেন? আপনি পারবেন না ভেরিফাই করতে। এটা ভেরিফাই করার একমাত্র ওয়াই হইতেছে সেফটি অ্যানালাইসিস করতে হবে। কিন্তু আমরা যদি ভেরিফাই না করে ছেড়ে দেই এবং ট্রান্সফরমার সব বসানো হয়েছে, এখন ওই রুমের ভিতরে 5টা ট্রান্সফরমার আছে, দেখা গেল সামনের দিকে যে 3টা ট্রান্সফরমার আছে ওই 3টা কুল হচ্ছে, পিছনের 2টা ট্রান্সফরমার এয়ারের ঠিক মতো মুভমেন্ট হচ্ছে না, ওই 2টা গরম হয়ে যাচ্ছে। তো এই জিনিসটা আমরা ফেস করব এক্সিকিউশনের পরে। কিন্তু সিএফডি অ্যানালাইসিস করলে আমরা হইতেছে কি, এই যে সমস্যাটা হবে ওই সমস্যাটা আপনার এক্সিকিউশনের অনেক আগেই, ডিজাইনের পরে আমরা জানতেছি জি এই জায়গায় সমস্যা হয়ে গেছে। তো আমরা এই প্রজেক্টে করছি কি, আমরা যখন ডিজাইন করার পরে সিএফডি রান করছি এবং ঠিক সেম জিনিসটাই হয়েছে, পিছনের 2টা গরম হয়ে যাচ্ছে। এবং সিএফডি অ্যানালাইসিসে ডাটাগুলি এমন ভাবে দেয় যে আপনার ফ্লোর লেভেল থেকে 1 মিটার হাইটে কতটুকু টেম্পারেচার হচ্ছে, 2 মিটারে কত, 3 মিটারে কত, কারণ আপনার ঠান্ডা হাওয়া তো নিচে দিয়ে যাবে এবং গরম হয়ে উপরের দিকে উঠে আসবে, তাই না? তো উপরের দিকে টেম্পারেচার বাড়তে থাকে। তো আমরা অ্যানালাইসিস করে দেখলাম যে যখন এটা 4 মিটার হাইটে যায় তখন টেম্পারেচারটা সবচেয়ে বেশি থাকে। তাহলে আমাদের কি করতে হবে, উপরের দিকে একটা ভেন্টিলেশনের ব্যবস্থা করে দিতে হবে, যাতে এই গরম বাতাসটা উপর দিয়ে বের হয়ে যেতে পারে। যদি বের হয়ে যেতে পারে তাইলে আপনার সার্কুলেশন হয়ে যাচ্ছে, তাই না? হ্যাঁ, তো আমরা এইভাবে এটা সলিউশন করে ফেলছি। কিন্তু আপনি যদি সিএফডি না করেন, এটা কিভাবে আপনি করবেন? এটা তো খুবই টাফ আসলে।
ওকে, থ্যাংক ইউ।
ওকে, ধন্যবাদ।
থ্যাংক ইউ। আমার মনে হয় আরেকজন একটা পার্টিসিপেন্ট, আমি জানি না অ্যাকচুয়ালি এটা ইউজার নেম ESL প্রজেক্টস লেখা আছে।
আচ্ছা, এটা সালাউদ্দিন ভাই
জি,
মনে হচ্ছে।
ও
সালাউদ্দিন
সালাউদ্দিন ভাই,
ভাই, আমি
আচ্ছা।
সালাউদ্দিন। আপনার ফার্স্টেই বলেছিলাম আমার আসলে প্রফেশনাল জিমেল অ্যাকাউন্টের ESL প্রজেক্ট নাম দেওয়া।
ও আচ্ছা আচ্ছা আচ্ছা,
So,
সালাউদ্দিন ভাই
and
প্লিজ।
again, I'm in this forum. This is my first time. That's why people maybe not get used to it. Next time, I'll change my name. And
No, no, no.
higher
Now
name.
now we know you
So,
about.
what I was actually going to ask is Kandabai to
Yeah.
you and to brother Ashraf Bhai about the HVAC session today. It is a brilliant and excellent session. This is so resourceful topics, but you know, I mean, I personally see you both, or there are many fellow professionals here could be, you know, equivalent to my teacher. I have learned HVAC design when I was doing 2003 a construction management degree here in UE in Bristol, in United Kingdom. And I had to do a project in central London at Paddington, the Point. It was like a C shape, I mean, C shape pattern shape of building. And on the HVAC, we had to do a practical course, and that was like air handling unit itself, where about probably 20 million pounds worth of project, and everyone has to do a different modules. So what Ashraf Bhai has covered, he mentioned in the very beginning that this is a intermediate equivalent mathematical calculation, but the topic is so practical. Without knowing the practical thoughts, no one would realize. And today, this minute, I'm sitting in my work desk. There is a heater running under my feet and next to my table. You know, the winter country. The main problem is the fabric, or the what's called the envelope of the building, where the U value that Ashraf has mentioned. With architects and engineers and structural engineers, the heating and convection of the what is called convection, isn't it? Yeah, radiation and convection. So there are number of challenges where it's a winter country like, you know, Canada, America, many states. HVAC is a key part for very small calculations for people's well-being. They call health and well-being, and breathing out, breathing in, and all these factors are actually accountable from the desk. You can't be actually ignoring any point. I think in 2000, when the pandemic session happened, I tried to reach out a startup competition in Bangladesh, and I tried to put this building thermology or thermal conductivity analysis for especially commercial buildings. And I think I wasn't actually being selected, even not shortlisted. No one probably have had actually seen my 20-page presentation, but I were intended to give this message that during pandemic, if there was any opportunity, we can find a what we call a all-weather comfort zone and well-being room, which could be out of 20 different units or 20 different spaces of commercial space in school, hospital, and many other commercial spaces. Just one particular area where the occupants would be actually be adjusted for a fully clean air, fully clean adjustable air. And this is not actually a focus from the concept stage or early stage. I'm quite often come to a point of asking, have you considered this? Have you considered that? And one of these good things that Ashraf Bhai has just today mentioned, it is a considerable, what you call the software available, CFD analysis available. In my time when I was started learning it, I was started learning by manual calculation, and I had to understand U value and airflow, and then people, number of occupants, and who is actually on what age group, the young kids, the older group, and then the middle group, what's their, you know, inhaling and exhaling temperature changes. And then also some other fabric like double glazing, single glazing, roof thermal conductivity, wall conductivity. Here in UK, you know that we are very well organized. They call sandwich building. It's like a cavity wall. But in Bangladesh, you got 10-inch or 5-inch wall, and then no window sometime, and people shivering all of a sudden. the temperature changes, and they got flu, they got pneumonia, and they all goes to a pandemic situation, like go to a hospital. Everyone is in a situation like, I think, many times people say everyone's house has got a জ্বর আর ঠান্ডার মধ্যে সবাই মরে যাচ্ছে. That's a simple topic, but it's actually start from the where the aesthetic values of the architects, engineers needs to be coordinated and work together to understand there should be a space in any single accommodation or habitation, whether it's a commercial or single residential building. The all-weather adjustable space should be focused, and then people well-being would be controlled. I hope I managed to give a question and answer together. Ashraf, I'm very sorry, I've not hijacked your presentation, but I'm overwhelmed. Excellent, well done.
Thank you, Salahuddin bhai. It's really, it's not a presentation, but whatever you have said, definitely this is right, and I think Engineer Ashraful Alam also have presented this very well. And thank you very much, Engineer Ashraf bhai. Do you have anything to say on Mr. Salahuddin?
No, thank you, Salahuddin bhai, for your appreciation and enlightening us from your experience. Yeah, thank you.
Okay, thank you. Now
Most welcome, all the time, every time.
Thank you, Salahuddin bhai, and I'd like to request Rajaur Rahman. Raja bhai, আপনি কি আসছেন? আমরা রেকর্ডিংটা বন্ধ করতে পারি এই সময়।
ইয়া আমি আছি। আচ্ছা, যাক, এটা শেষ করার আগে আমি করতেছি যে আমাদের নেক্সট যে 6 ডিসেম্বর, আপনারা জানেন যে বাংলাদেশের রিসেন্ট যে আর্টওয়ার্ক হয়েছে, সেটার জন্য আমাদের স্পেশাল কিছু সেশন হবে। তার মধ্যে প্রথম সেশনটা হবে 6 ডিসেম্বর। এটা টপিকটা হবে
রাজা ভাই, আপনার এটা মিউট আছে এখন।
আচ্ছা, সরি, এটা মিউট আছে, আমি আসলে খেয়াল করতে পারিনি। সেশন শেষ করার আগে আমি জাস্ট কিছু পয়েন্ট করতেছি। সেটা হচ্ছে যে আপনারা জানেন যে রিসেন্টলি বাংলাদেশের যে আর্টকোয়েক হয়েছে, সেটা আমাদের আসলে সিরিয়াস কনসার্ন, যেটা হোল ওয়ার্ল্ডের ডিফারেন্ট কান্ট্রিতে হয়েছে, এবং এটা ডিজাস্টার হয়েছে টার্কি এবং ডিফারেন্ট কান্ট্রিতে। এই জন্য আমাদের এই অ্যাওয়ারনেসের পার্ট হিসেবে আমরা কিছু সিরিজ প্রোগ্রাম করব। তার মধ্যে প্রথমটা হবে 6 ডিসেম্বর, সেটা সিসমিক হ্যাজার্ড, ভালনারেবিলিটি অ্যান্ড রিস্ক অফ বিল্ডিং সিস্টেম এ পার্সপেক্টিভ অন বাংলাদেশ। এটা নেবে স্পিকার হবে ডক্টর রাম কৃষ্ণ মজুমদার, অ্যাসিস্ট্যান্ট প্রফেসর, ডিপার্টমেন্ট অফ সিভিল ইঞ্জিনিয়ারিং অ্যান্ড কনস্ট্রাকশন, জর্জিয়া ইউনিভার্সিটি. He was also the assistant professor of CUET. Okay, hopefully everybody will enjoy. And apart of that, everybody knows that we have one program of student public speaking program. So this public speaking program will start end of December. So I request who are in student level or the engineers who have a student in your family, your son or daughter, we encourage to participate in student public speaking program. So hopefully we'll start 3rd week of December. So everybody is invited there, because we want that our new generation will grow in the global competitive market and build the leadership to glorify our nation and Bangladesh. And I want to tell that in our BEAWorld is basically everybody's platform. This is entirely for professional development. We don't have relation to anything out of our scope. So I request everybody to come up, who wants to conduct the session or who wants to write the article. We have a magazine, Synergy magazine, we'll publish in the website. And we want to build BEAWorld as a global knowledge building hub. So that's why everybody is requested to come up and make it as a successful platform. Thank you very much.